So today we'll be studying something called as perspective projection. So basically, what is perspective projection? Perspective projection is nothing but what you can see from your naked eyes. So basically, if you stand little far from a tall building, suppose if you stand in front of India Gate, like little far, what you can see is not the exact size of the building. So that is called as your perspective of that object. So this, as you can see, this is called as a picture plane. So this is an original object which is of this size, this much size, but what you can see is only this much. So this is called as a perspective projection. So let us consider one question. In this question, it is given that a square prism of 30 mm side of base and height 50 mm rests with one of its base on the ground such that one of the rectangular faces is touching the picture plane. The station point lies on the center line of the object 60 mm above the ground and 50 mm in front of the picture plane. Draw the perspective view of the square prism. So let us consider the square prism first. First, for that I need to draw a reference square of 30 mm size. I'll draw a 30 mm size square for the reference. What I need to do now is I need to take a picture plane. That is where my structure rests. So I'll just consider a light line just a distance away from the square. So here I can see, I can indicate this as PP. That is nothing but picture plane. On top of this picture plane, I am going to rest this square. This is only the reference square I have drawn so that I could easily drag in the square here. So again I have drawn the same square here. So see now, this is my square. What I need to do is I'll have to first identify my midpoint. So I have got my midpoint now. Now I need to indicate the square. For instance, I'll consider this as my square prism. So what is happening here? This is my front square side which is lying on this line. This is this picture plane. I need to indicate so as this point is called A, this is B, C, D, and similarly if you turn it back, again it will become A1, B1, C1, D1. Or you can also indicate it as A1, A, B, C, D, E, F, G, H. It's your wish. So let us first start indicating it. So I'll consider it as A1, which is falling back, so I have to write it in the bracket. B1, B, C, C1, D, D1. Okay. After doing this, what you need to do next? As given in the question, what is the height of the height of the square prism? That is nothing but 50 mm. So what you need to do is you need to take a distance of 50 mm below the square lamina. What you need to do is you need to take a distance of 50 mm or 5 centimeter. Just draw a light projection line. That is for your reference. So what you need to do next, you just need to drag So what do you need to do is, you need to drag the midpoint downwards. Then you need to bring all the points here to join the point at the point ST. This is called as ST, station point or station. This you need to join with these points. So what you need to do is, you need to bring in all the lines, light line, raised projection lines, adjoining the point ST, which is to a distance of 50 mm. I'll write it 50 mm. Okay. Now what you need to do, you need to bring these edge lines down. Just draw a regular line, and what you need to do is just draw all the intersecting point line also downwards. So this is one intersecting point, this is another intersecting point. Okay, this is how you're supposed to do. Till here it is done. Now what you need to do next is, you need to take a ground line to some distance. You can take any amount of distance. Just make sure here it is clearly mentioned that 60 mm above the ground. So what you need to do, it has to be little more than 60 mm. So what you need to do, I have taken some random distance. I will be just dragging all the projection line downwards like this. Then similar to this, what I have to do is, this is called as GL, that is ground line. Above the ground line, I need to take a reference point of 60 mm. Just draw a light projection line from here. I'll indicate this also as 60 mm. Okay, after drawing this is the place where you will be getting the actual picture. The actual picture, what is visible from your naked eyes. So how you need to draw that? What you need to do now is, as clearly mentioned in the question, it is the square prism of 30 mm is lying, so that 50 mm, the height of the 50 mm side is resting on the ground, such that one of the rectangle faces is touching the picture plane. So what they are telling is, considering this is lying. So this is lying like that. This is my picture plane below this. So what is happening? Can you see this area, this portion? This portion is nothing but falling on the picture plane like this. If I consider this as the picture plane, this scale as a picture plane, and this is my square lamina, what is falling exactly, what is resting on the picture plane? That is this portion. So if this is resting on the picture plane, this is what we can see from our naked eyes. So this is the actual size. So this rectangular face has to be kept with its actual size. So what we need to do for that? What we need to do for that is, we need to just draw the actual size of the rectangular portion. What is the actual size of a rectangular portion? Clearly mentioned in the picture, it is 50 mm height. So 50 mm height means I will take it to a height of 50 mm from the GL. 50 mm height. Okay, so this is my actual face. That is what the face which is sitting on the or resting on the picture plane. This face, it will be seen like this. So now next what we need to do is, we need to exactly like what we did on the square plane, we need to bring in all the Join all the corner points to the midpoint. So look at me, I'm just joining all the points. Now you see, can you see this intersecting point? This is nothing but your back side or back edge of the prism. So I'll just draw the I'll just adjoin these two intersecting point, and what I'll do is I'll connect these points to this line. You can clearly, you just keep watching how it will automatically turn into a like square prism. Now you got a side which is standing like this. This is that side which is sitting like this. If I keep my eraser, can you see my, if I keep my eraser, I'm standing in front. The eraser shadow also, see, if you can see, the shadow will look like this. It will be like a little bit elongated or a little bit twisted. So that is how this lamina is formed. Now after that, what you need to do? After this, you need to join these 2 points also to the midpoint. Just light projection lines. Okay. Now again you can see, again there is one intersecting point, another intersecting point. Just join these 2 points also. But if I'm standing like this straight in front of the drawing, I can clearly see this portion of the drawing. So what will happen? This will not be a dotted line and it will be a dark line. Now see, can you see this rectangular portion at the back? That is nothing but another side of the rectangular, another rectangular side of the square prism. Now just imagine, I'll just erase this for your reference. You don't need to erase it, just draw a little lightly. You can clearly see a square prism formation, which will not look exactly like a square in the actual picture. Okay, now I'll start with the indication. This point where all the corner points will be adjoining. This is called as VP or called as vanishing point. Why is it called as vanishing point? You can clearly see, you can clearly imagine with the name itself. After joining all these points, here the edge is getting vanished. So this point is called as vanishing point, where the lamina is already found. The square is already formed in the top, and here it is vanishing. So this is called as VP or vanishing point. So next what I'll do is I'll start with the indication. It will become larger A, B, C, D. Then again the bottom one will become A1, B1, C1 and D1. Because this is your actual figure, I have to indicate it with a bigger numbers, bigger alphabets. So now, for your reference, what I'll do is, I'll just draw this at another side, just below the square which is drawn in the top, at the top. I'll drag it down. It is of same height. So this can be indicated as A1, D1, because see, this is A, this is at the back D. So I'll have to indicate it with A1, D1. This is your front view. Then again C1, C dash, B dash. So how you need to indicate this? A dash, D dash, C dash, B dash, because it is front view. A1 dash, D1 dash, A1 dash, D1 dash. Then again C1 dash, B1 dash. So this is entire question solved. Okay, this is how you're supposed to solve the question of a perspective view. Understood? It's very easy, but you just keep this question at for the last. Do not try to do at first. Just keep this kind of question at the last. So people who are willing to attend this only can attend this. Other than that, you can just try for this, but do not waste your time, because there are a lot of intervening points to join here. And if you try to do this and waste your time for others, like building planning is a main part which you need to finish. So you just keep this one for the last. Okay. So this is how you're supposed to draw the perspective view of a square prism. Thank you.